In this video, we're going to look at how to solve simultaneous equations when there are both linear and quadratic equations. We will then look at some of the common question types, including how to determine the number of solutions ahead of time, and how to solve them when there is an additional unknown variable k. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defence company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. If you're just trying to solve a set of simultaneous equations, then it doesn't really matter what those equations are. You still use either the substitution method or the elimination method. For this scenario here, usually the substitution method is the best. When you solve simultaneous linear and quadratic equations, there are three possibilities. The first is that there is one solution, and that graphically looks like this. We have our quadratic, and we have a linear that is brushing up against the side of that quadratic. It only intersects at one spot. The second possibility is that there are two solutions. And in this case, it just means that your linear has crossed through the graph twice, at two distinct points. And the final possibility is that there are no solutions, in which case the graphs don't touch. Let's try an example. So, the first step in using the substitution method is going to be to sub equation 1 into equation 2. All we have to do now is solve for x. Now, if we're looking at this equation, we can see that the highest power in the equation is just 2. That makes this equation a quadratic, and so we solve it like we would for any other quadratic. So with that in mind, we're going to start by getting all terms over to the same side and then simplifying. Now we can just solve however we like. I'm going to use factorization, but you can use pretty much any method you want. You could complete the square, you could use the quadratic formula. Those methods will just take a little bit longer than if you would just use factorization instead. In this case, we see we have two unique solutions. Now, most of the time this is all you need, but in some questions it might ask you for the specific coordinates as well. So to get the corresponding y coordinate, all you're going to do is sub in the x coordinate back into either equation. The linear is going to be the easier one to sub into. Sometimes you're going to be required to determine the number of solutions ahead of time. If you remember from your previous studies in quadratics, you would know that the discriminant was one such equation that could do this. Let's see how to apply it. For now, we're just going to keep everything generic. We have a generic quadratic equated to a generic linear. And if you remember from the previous example, the first step there was to get all the terms on the same side. So let's do that. We should also collect the like terms too. And once we do that, we're going to find that we have a quadratic, albeit a more complicated quadratic, but a quadratic nonetheless. So if we want to know the number of solutions that this quadratic has, then we find its discriminant. The rules are the same. If your discriminant is positive, you're going to have two solutions. If your discriminant is equal to 0, you're going to have one solution. And if your discriminant is negative, you're going to have no solutions. So let's try to solve the discriminant of the previous example. Once again, we're going to start by equating both of the equations and then getting everything over to the same side and collecting the like terms. Once we have that, we're going to find the discriminant of that quadratic. And when we do, we see that we get a positive result. Hence, we expect two solutions, which is what we got. The last thing we're going to look at is how we can solve literal versions of these equations, which just means that the question now comes with an additional unknown variable, usually k, and you're going to be asked to solve for k such that you get one of the three scenarios from before: two solutions, one solution, or no solutions. This is where the discriminant comes into play. And what you'll find is that when you find the discriminant, you're going to have some unknown k in there, and you're just going to rearrange to get k on its own. Let's look at a few scenarios. For one solution, we need our discriminant to equal 0. So that's what we're going to do. Well, just like before, we start by equating both equations together and then getting everything to the same side and simplifying. From there, we're just going to find the discriminant of that quadratic and set it equal to 0 because that's the criteria for one solution. All we do from here is solve for k. This is just a linear equation, so there's nothing special going on here. All we do is just rearrange for k, and we're going to find that our solution is going to be k equals negative 13. Alright, same set of equations, but different question. This time we want two solutions, which means our discriminant needs to be greater than 0. So we just follow the same steps as before. Equate the equations, simplify everything onto the same side, and then find the discriminant. But this time we set that discriminant to be greater than 0. We're now solving an inequality, but it is still just a linear inequality, so there's nothing too special going on. Once we solve our inequality, we're going to find that our solution is going to be k is greater than negative 13. Once again, same set of equations, but this time we want no solutions, which means discriminant needs to be less than 0. So once again, we follow the same steps, get to the discriminant, make it less than 0, and after simplifying, we're going to see that we get k is less than negative 13. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool. You should check it out. I'll see you there.